Yes. Yeah, good evening all. So myself, I'm Vijay. Like I hold 20 plus years of experience in different technologies. So before I go, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. Anyone try to confirm me? Is my voice clear to all? Is my voice audible to all? Yes. Thank you. I got enough confirmations. Yeah. So what is big data and why Hadoop is required? Drawbacks with the current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yes. Big data, the name itself saying like huge volumes of data, right? Yes. Check this. Mm. Today, if we talk about the data storage units like KBs of data, MBs of data, GBs of data, TBs or petabytes. Today, data has reached petabytes. 1 petabyte equal to 1024 TBs. Already, TB is a large storage unit, but still today data is generated in petabytes. Examples of petabytes of data generation. Examples of petabytes of data generation. If you talk about any bank, take example of an SBI bank or an HDFC bank, right? So within the city, you see hundreds of branches. Within the city, hundreds of branches for SBI. Within the entire state, thousands of branches for SBI. Within the entire country, lakhs of branches for SBI. So within this lakhs of branches, again, millions of customers making multiple transactions per hour, per day, per week, per month. So you see like huge transactions here. Forget about this bank. If you're aware about the social media like Facebook, millions, it has got users throughout the world, not only within the country, it has got users throughout the world. Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What should be the storage capacity for storing all these videos, right? Okay. The data generated by Facebook is not in GBs, in MBs or GBs, in terabytes or petabytes of data it is going to be generated. So if you take 1 minute transaction, if you take 1 minute transaction, right? If I 1 minute transaction, just for 1 minute, in 1 minute, see the various applications, not only Facebook. Today, if you see, many applications are generating data in petabytes. Many applications are generating data in petabyte, like Facebook, Twitter tweets, Google queries, YouTube videos, Gmail messages, bank transactions, telecom transactions, e-commerce transactions. So here all these things, right, where you can see like huge data is getting generated from all this, like millions and trillions of users per Gmails, their messages means it has to be stored. We need to store all their messages, like huge storage. YouTube videos upload million. YouTube videos upload. What should be the storage capacities for storing all the videos? Just now I was talking about bank transactions, telecom transactions, e-commerce, Flipkart or Amazon transactions, right? Everywhere you see like huge data is getting generated. Currently, we have got a databases like Oracle, MySQL, DB2, SQL Server for OLTP operations. Online transactional processing, right, for day-to-day operations. But we have got some specialized databases. If you heard about these databases, specialized databases like Teradata, Netija, Vertica, these are the specialized databases used for data warehouse for OLAP operations. But these databases are specialized databases. They can handle data up to some extent. But for unlimited data storage, for huge or unlimited data storage, right? We have got frameworks like Hadoop. So later I'll come back with this. What are the Hadoop services? But if you see how the data is getting generated today, right? If you take the data which has been generated from the last 50 years, Assume this is your data which has been generated from the last 50 years. This data has been generated from 1975 to 2025. If we compare last 10 years data, means 2015 to 25, and the previous 40 years. This is your data. Nearly 80% of the data what we are seeing, right? 80% of the data has been generated from the last 10 to 15 years. Only 20% of the data in the current real world has been generated from 1975 to 2015. What is the reason for huge data generation, especially from the last 10 years? What is the reasons for huge data generation, especially from the last 10 years? Means usage of technology, usage of smartphones, usage of internet. Because of this, like huge data is getting generated everywhere. If you see in 1990s, the storage, if you see the secondary storage, like we used to carry floppy disks, 1.44 MB. In that, you used to store multiple many images. Today, in a floppy disk, you cannot even store one smartphone image, smartphone picture. Later, we got D series, compact disc, DVDs, later like USB pen drives. So data is increasing, right? Data is increasing, so even the storage capacities has to be increased. And from what are the main sources from where this data is getting generated? What are the main sources from where this data is getting generated? Mainly three sources of data. Mainly three sources of mainly three sources of data. Social data. Secondly, like machine data. Social data, machine data, and transactional data. Social data, machine data, and transactional data. Social data means data which has been generated from the social websites like Facebook, Twitter, all these things, right? Yes. Machine data means data which has been generated by reading or scanning the barcodes, the RFID chips, right? For the items you purchase, right? A huge bill is generated. So such kind of data we call it as machine data. Transactional data means data which has been generated from day-to-day operations, like telecom transactions or bank transactions. Or if you talk the data which has been generated, it's going to take three types, three formats, three types of data. Structured data, semi-structured, unstructured. Semi-structured means data which is organized in the form of rows and columns in a structured format like database tables. Semi-structured data like XML files, JSON files. Unstructured like short messages, articles, images, videos. So data is going to take structured data, semi-structured and unstructured. Structured data which is in the form of DB tables, Excel files, XML, JSON. Unstructured like chart messages, articles, images, and videos. As a solution to all the storage level problems and processing level problems, we have got a framework like Hadoop. Hadoop is mainly for two things. Hadoop is mainly for two things, for storage or for processing. It is for storage and also for processing. Any technology performs either storage or processing. C or C++ or Java or .NET, all these they are meant for processing. Oracle, MySQL, DB2, all these are meant for storage. So all these are meant for either storage or for processing. These are meant either for storage or for processing. But Hadoop performs both storage and processing. That too, unlimited data storage. Unlimited data storage, right? Yes. For storage, HDFS, and for processing, previously we used MapReduce. Now we are going with Spark. Yeah. For storage, we have got HDFS, and for processing, we are going with Spark currently. So if we take like big data, if we take big data as a problem, huge data generation. If we take huge data generation, big data as a problem, Hadoop is the solution. If you take big data as a concept, Hadoop is the implementation. So for huge data storage and for huge data processing, right? We have got this. Yes. Yes. So now, just to go with this, Hadoop is meant for storage and processing. For storage, HDFS. For processing, MapReduce or Spark. Hadoop is not for online applications. Hadoop is not for online processing or not for online applications. Hadoop is for batch applications. There are two types of applications mainly. There are two types of applications. Online applications, batch applications. Online applications means user interactive applications. User interactive applications. Here user gives the input. Booking a movie ticket, making a online payment. Okay. User gives the input, booking a movie ticket, making an online payment, right? Batch application, user non-interactive applications. User non-interactive applications. Here user is nowhere required. Here user is nowhere required. So railway ticketing PNR status means here online means user interactive, batch means user non-interactive. Here user gives the input in the case of online. So you are booking a movie ticket means compulsory you has to give the input, making the online payment, the source, destination, everything you need to provide. So it's a, but in the case of batch applications, user non-interactive, user is nowhere required. Railway ticketing PNR status, currently your status is 200 after currently your status is 200. After 1 hour, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Okay. So it is everything happening in the background. Here user is nothing to do. User is nowhere required. Generating credit card statements for millions of customers, right? Here also user is nowhere required. And mobile statement, mobile bill generation. Railway ticketing payment status, generating credit card statements for millions of customers. Right. Now you may ask, for storing, we are using a file system called Hadoop distributed file system. Why databases can't be used? Why databases can't be used for storing Hadoop's data? Drawbacks with the current databases. Why databases can't be used? Drawbacks with the current databases. Most of the databases, a limited storage or very less storage or limited storage. In most of the databases, no parallel processing with. And here, if volume increases, speed decreases. Means just observe here, volume increases, speed decreases means just check with this query. Total amount from sales one. Select total amount from sales one, 10 records. Total amount from sales two, 10 lakh records. Total amount from sales three, 10 crore records. Total amount from sales one, 10 records. Total amount from sales to 10 lakh records. Total amount from sales three, 10 crore records. 10 records, 10 lakh records, and 10 crore records. Which query is going to execute faster among these three? Yes. Which query is going to execute faster among these three? Obviously, the first query. Total amount from sales one. Means this query is going to execute faster, right? Because only 10 records as compared with 10 lakh or 10 crore records. So first record executes faster as compared with the next one. Yes. Whenever complexity increases, next year one more drawback with the current databases. If complexity increases, like speed decreases, total amount from sales one from 10 lakh records, average amount from sales one, 10 lakh records, and standard deviation of one from sales one. So same 10 lakh records, same table name. Which query execute faster among these three? Which query execute faster among these three? Here also the first query, right? Sum of amount from sales one. Sum of amount from sales one, right? As compared with the average means average amount is a two-step process. First sum has to be calculated. Next average has to be calculated as compared to the first query. Second query is time taking, right? And standard deviation means lot of internal processing required. Lot of internal processing is required as compared to the first and second. The last one takes more time. So here as complexity increasing, right? Speed decreasing. And the major drawback with that databases can handle only structured data. Major drawback with databases is it can handle only structured data. It cannot handle unstructured or semi-structured data. Handling only structured data. It cannot handle unstructured or semi-structured. Check with this example, right? Yes. Hmm. I want to take reviews for a particular movie. I want to take reviews for a particular movie. So see this is the table. User 1, user 2, 100 users. The movie is good saying 1. If the movie is bad saying 0. If the movie is good saying 1. If the movie is bad saying 0, right? They're giving that feedback in the form of zeros and ones, right? Yes. Now can you write the total number of people who are, means how many goods and how many not goods? How many goods and how many non-goods, right? Can you write an SQL query to count the number of ones and zeros so that you get the count of number of goods and not goods? Single grouping, single aggregation, single grouping, right? Review wise I want. Select review wise count I want from reviews. Group by review. Review wise count from reviews, group by reviews. Okay, 1 and 0. Review means 1 and 0. How many people saying 1? Okay, think that 90 people, once 10 people saying 0 means 90 people saying the movie is good, 10 people saying that movie is bad. But generally, reviews won't be given in this way. They'll be given in their own text format. Movie, first person saying movie is good, second person saying movie is not good. In this way, they are given, right? Yes, movie is good, movie is not good. Can you write an SQL query now saying that how many people saying good and not good? Previously, you are able to count the goods, ones and zeros. So now, can you able to count the goods and not goods here? Even if you try to count by using that keyword good, right? It gives wrong computation because even not good has got good in it. So a wrong computation. So databases cannot handle such kind of data. Okay. Okay. Limited storage, no parallel processing, right? Volume increases, speed decreases, complexity increases, speed decreases. Databases can handle only structured data. Okay. Hadoop. Before we go with the Hadoop advantages, you need to know something about this Hadoop architecture. Hadoop follows a client server architecture. Hadoop doesn't follow client server architecture. Sorry. Hadoop follows a master slave architecture. Hadoop is not for request response architecture, not for client server. It follows master slave architecture. Single master and multiple slaves. Single master and multiple slaves. Hadoop cluster, group of nodes connected in a network. Group of nodes connected in a network. There are two types of nodes. Master node, name node. Sorry, master node or name node, slave node or data node. Two types of nodes. Check this right? Yes. This is master, these are slaves. S1, S2, S3, so on, Sn. So this is called as master node. This is called as master node. Within the master node, we see name node. Slave nodes are data nodes, we say. Slave nodes. Data stored by the slaves and data processed by the slaves. Data stored by the slaves and data processed by the slaves. F1.txt. See here, each system capacity is 1 TB, 1 TB, 1 TB. F1.txt size is 2 TB. This 2 TB file cannot be accommodated in any of the systems. Slaves means systems nodes. So what we do generally in Hadoop, this file will be divided into smaller parts. It will be divided into smaller parts. Each part is distributed across multiple systems. So Spark data file is divided into smaller parts, and each one is distributed across multiple systems or slaves. So here two advantages: distributed storage and parallel processing. Means single file data distributed across multiple systems and processed by multiple systems parallelly, working on the single data file. So this master nodes assigns tasks to the slaves. T1 task to slave 1, T2 task to slave 2, T3 task. So T1 task, T2 and T3 assigning tasks. So what is master node responsibility? Task assignment and load balancing. Master node balancing the load equally to all the slaves. Fault tolerance means, observe this diagram. When multiple tasks are executed by multiple systems, suddenly if any one system goes down, then the task of it will be assigned to any of the other slaves. This process is called as fault tolerance mechanism. When multiple tasks are assigned to multiple system, if any one system goes down, then the task of it assigned to any of the other slaves. This process is called fault tolerance. Okay. And health monitor. Before assigning tasks to any slave, the master node will have the health status of each and every slave node responsibilities. Storing data and processing data. What is slave node response? Storing the data and processing data. So now coming to the Hadoop advantages. Unlimited data storage is possible. Very high speed processing can handle all varieties of data. Is an open source commodity hardware. Unlimited data storage, right? Because of horizontally unlimited scalability. Unlimited data storage is possible because of horizontally unlimited scalability. For example, if you're running a business with very less number of slaves, you're running a business with very less number of slaves. S1, S2, S3. You've got 10 systems. Assume you've got very 10 systems. So your customers are increasing, branches are increasing. If customers are increasing and if the branches are increasing and data also increasing, right? So horizontally, you can keep on increasing the systems. Means horizontally unlimited scalability. Horizontally unlimited number of slave systems can be added. Yes. Very high speed processing because of parallel processing. Very high speed processing means multiple systems are executing parallelly. Parallel processing. Multiple systems are executing parallelly, right? Yes, executing multiple tasks. So parallel processing can handle all varieties of data, can handle all varieties of data, structured, semi-structured, and unstructured. It is an open source. It is an open source. No licensing. So most of these Hadoop products are this from you can take it from Apache Mirrors, can download and install. Commodity hardware doesn't mean that you need to have highly configured systems. It can run on any hardware configurations. Right. Yes. Now, Hadoop is proven in the market, storage point of view and processing point of view. What? Okay, here Yahoo has taken a table of 100 TB consisting of 1024 columns. Task was sorting based on 16 columns and time taken by different databases, right? Oracle has taken nearly 3.5 days to process this. MySQL has taken around 6 days to process. Teradata has just taken 4.5 hours. Teradata has just taken 4.5 hours. Netija has taken 3 hours. Netija has just taken 3 hours. Hadoop has taken, see, these have taken days of time. These are taken hours of time. And Hadoop has taken minutes of time. Hadoop has just taken minutes of time. So the latest version of Hadoop has taken just 1.2 minutes. This is the speed of Hadoop as compared with these things. These have taken days and hours. But Hadoop speed is very high, but Spark is 100 times faster than Hadoop. Already Hadoop has got very high speed, but if we talk about the Spark has got very high speed. Why databases like Oracle won't support unlimited store? So here Hadoop is proven in the market processing point of view with a very high speed of rate. Hadoop and Spark both commonly used today. Why databases like Oracle won't support unlimited storage? Databases, even databases can go with multiple systems or slaves. So what is the max limit on the number of slaves? Oracle can go maximum to 56 nodes or slaves. MySQL can go up to 54. MySQL Express can go up to 256 nodes. SQL Server, DB2. All these databases can go maximum up to 256. Beyond that, no. If exactly 256 systems given, if 250, all the 256 systems gets filled, the performance of the system degrades. Sometimes it won't even start. But there are some specialized databases like Teradata, Netezza, Vertica. They have got 512, 512, 512 nodes. But currently they are supporting 1024, the first two, Netezza and Teradata. So none of these databases are specialized databases are holding huge data or unlimited data, right? But there's no limit on the number of slaves that Hadoop can have. Yahoo, when first time implemented Hadoop, it went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Right. Currently, Yahoo going with 12,000 nodes for storing its data. Facebook, when first time implemented Hadoop, went with 8,000 nodes. Currently, Facebook going with 52,000 nodes. Currently, Facebook going with 52,000 nodes. Okay. So Hadoop is proven in the market. Hadoop is proven in the market. Storage point of view and processing point of view, right? Storage point of view, like storing unlimited, means there is no limit on the number of slaves, and processing point of view, very high speed. Yes. Now, also some small introduction to this Apache Spark. What is Apache Spark? Why PySpark? Need for PySpark? Real life usage of PySpark? PySpark job market, right? Yes. Okay, if I talk, Apache Spark is an open source distributed cluster computing framework by Apache, introduced by Apache Software Foundation. It is a general engine for big data analysis, processing, and computation, right? Why PySpark? I can say PySpark is a Python API to use Spark. Yes, PySpark is the lightning fast technology that is designed for fast computation. It is a very demanding tool among data engineers to work with bigger data sets. PySpark is used for running distributed SQL, creating a data pipelines, ingesting data into database, running ML algorithms, working with graphs or data streams. Running distributed SQL, creating data pipelines, ingesting data into database, running ML, right? Yes. Running ML algorithms, graphs, and data streams. See, need for PySpark means huge amount of data is getting generated both through online and through offline. This data contains unknown patterns, hidden corrections, market trends, customer preferences, and other useful information. But it is necessary to extract valuable information from the raw data. So we require a more efficient tool to perform these kind of operations. Already we have got many tools available for these things, but they are not so appealing. So we require some scalable and flexible tools to crack big data and gaining benefit from it. So PySpark is such a kind. So PySpark is such a kind, right? Yes. So combining combination of Python and Spark will be the very efficient for the world of big data. So that's why Apache Spark community came up with a tool called PySpark, Python API to use Spark. And what are the real life use cases in this means? In the commercial sector, like uses commercial sectors uses Apache Spark real-time processing, like banks and other financial fields. They use the Spark to retrieve the customer social media profile and analyze to gain useful insights which can help to make the right decision. Okay. Now, even in this healthcare, right, in identifying the patients who are going to face the issue, even being discharged from the clinic, and even for the entertainment industry, the popular OTT platform, right, Netflix that uses Apache Spark for real-time processing. It processes around 450 billion events per day that are streamed over server-side applications, trade and e-commerce, like websites like Flipkart, Amazon, all these, they use Apache Spark for advertising. Even other websites like Alibaba, all this, they provide enhanced customer experience and overall performance. Even for tourism industry, Apache Spark, it provides millions of advices to millions of travelers by comparing hundreds of tourism websites, right? So everything. So as part of this course, right? So now coming as per this, discussing about this course, what are the things we are going to discuss as part of this course, right? So big data, it's a package that which consists of multiple things. Big data. First thing is Hadoop. PySpark, Linux, and Python. So this Python around this Hadoop PySpark and Linux, it goes around 12 weekends. And this Python that is required for this PySpark, right? So it will be from Monday to Friday. Monday to Friday. And this Hadoop PySpark and Linux in the weekends, and like Saturdays and Sundays, Saturday 2 hours, Sunday 2 hours, it will be there. Or it goes for 12 weekends. Okay. And this Python you need to attend from Monday to Friday, either morning or afternoon. Morning, there's a batch at 7 a.m. This coming day after tomorrow, Monday, at 7 a.m. you can attend. But first 1 week it will be at 7 a.m., but later it will be at 6 a.m. The original timing of this is 6 a.m. And one more, if you're not able to attend in the morning, evening, this coming Wednesday, I'm discussing Python at night 10 p.m. For first 1 week, it will be at 10 p.m. Later, it will be at 9 p.m. Right? You can attend any of my batch once you got enrolled. So this morning or evening, any one batch you can select. So it goes for Python around 1.5 months. We'll be discussing about core and advanced everything in brief in Python. Because to have command on this PySpark, you need to know about this Python core and advanced. And these things will be in the weekends. So what are the offerings? Before I go, what are the offerings? Just once check this course content, right? Yes. Everything in brief. Big data. What is big data? Why Hadoop? Need for Hadoop. HDFS. Hadoop distributed file system. MapReduce previously it was used a lot, but now this is not that much used, but just I'll give some kind of discussion on that. Scoop is also mostly used for import-export operations, for importing into Hadoop and exporting into other environment, and different operations like filtering, grouping, merging, many different operations you can do during this import. Incremental imports, incremental loading, defining scoop jobs, yarn yet another resource negotiator, and yarn components, yarn architecture, NoSQL database, different types of NoSQL database. HBase is one of NoSQL database I'll be discussing in brief. Performing CRUD operations, and one important component of Hadoop, Hive. Hive is one of the important component of Hadoop. You can see there are a lot of jobs available on Hive, right? You can see there are a lot of jobs available on Hive. Hive jobs, you can say. Hive jobs. Lot of jobs for Hive. So here 15,604 Hive job vacancies in June 2025. So if you know only this Hive in this lot of jobs for it, yes. That's why we'll be discussing in brief Hive query language, difference between HQL, SQL, loading data from local files to Hive tables, loading from HDFS to inner tables, external tables, working with unstructured, working with XML, JSON, URL, weblog, UDF, UDAF, UDTFs, indexing, bucketing, partitioning, indexing and bucketing, Hive and HBase integration. So these are the things in brief I'll be discussing. And PySpark, need for PySpark, why PySpark, real life use cases, PySpark RTD computations, persistence options, PySpark core computing, groupings and aggregations, various actions and transformations, PySpark SQL data frame API, PySpark creating a data frame, converting RTD to data frame, show row class, with column rename, drop duplicates, order by union, UDF, flat maps, and PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, built-in functions, various built-in functions one by one with many working examples, external sources, Spark and Hive integration, Spark and MySQL, and transformations, null and void transformations, handling nulls, writing data back to external sources, deployment modes, local mode, cluster mode, data by Spark application, states and tasks, drivers and executors, building Spark application, and PySpark streaming concepts, integration with Kafka. Even some streaming components like Kafka I'll be discussing. PySpark, ML, machine learning. Yes. So this is the Python course content, right? This everything is the Python course content. In brief, in this Python, in brief of this PySpark, and Hadoop and Linux. How much required, that will be discussing Linux, right? And as session videos will be getting soft copy of this class notes, assignments and tasks to work with. A WhatsApp group for this, for technical discussions, interview questions, and all are interactive sessions. So for everything, right, you'll be responding. At any time, you can ask the queries during the session, or you can have any queries or any errors, right? You can take the snap and post in the WhatsApp group. No need to wait until the next week, right? So this is what the entire thing. Fine. So tomorrow also you can attend the session same time at 3:30. Same time at 3:30 to see more discussion on this. Follow the same link for tomorrow's class. Yes. Any queries you got anywhere? Right. Any queries you got as part of this?
Yeah, Shantanu this side, sir.
Yes.
Yeah, actually, is there any difference between PySpark and Spark?
Spark means implementation with Scala language. PySpark means implementation goes in Python. So
Python.
previous Spark by default built using Scala language. Previously Scala was used a lot in 2016, 17, 18, 19. But today PySpark is mostly preferred, right? Spark with Python implementation. The
Okay,
Spark,
now,
what all the
yes, sir.
Spark related behavior, functionalities, everything remains same. Only the programming will be changed.
And MapReduce is replaced with Spark, right?
Yes, yes.
Yeah, okay. So Scala is also replaced with PySpark.
So in some companies they'll be using Scala, but most of them they are using Python today, because especially for this ML algorithms, for ML things, right? Python is mostly preferred. But
Mhm.
previously Scala was used a lot, I said, but now Python is used. But some companies still they are using Scala.
Okay, Spark, earlier you told, right? Apache Spark, we are talking about the same thing.
Yes, yes.
Okay, okay, sure.
So everything in brief, in depth, will be discussing about all these things, right? Yes.
Okay, sir, thank you. I'm good. I'm good from my end.
Any other queries, right? Anyone? Okay, so tomorrow you can attend the session same time at 3:30 using the same link, more discussion, right? If I'm done with the queries, if there are no other queries, I'm signing off for now. Meet you tomorrow. Bye.
Yeah,
Thank
thanks.
you all for, thank you all for your time. Thank you.